My name is Furst, and I am the Paul M. Cook Career Development Professor of Chemical Engineering. I started at MIT in 2019, and my lab generally focuses on energy equity. That's the idea that marginalized and disadvantaged communities have been disproportionately impacted by industrialization, and they're often left out of the conversation and technologies to combat the challenges associated with that and the kind of pollution associated with that. So the idea of energy equity is that as researchers, it's our job to develop technologies that are accessible, and also we strive for energy justice, which is to remediate those prior harms. I get made fun of a lot by my students because I always say microbes are the coolest. Microbes can pretty much do everything that we've tried to do chemically. They're like tiny little chemical factories that can produce whatever we want, and they have 4 billion years of evolution on anything a student can do during their PhD. So we try to harness what nature has already evolved to produce green materials, to make probiotics and other biotherapeutics that can help humans, and also to make processes like agriculture more sustainable by using microbes that would natively be in the soil instead of chemicals. One of our major breakthroughs in that area is that, surprisingly, many microbes, when you take them out of their comfy, cozy home wherever they live, they don't like to keep living without their neighbors and without the nutrients in that environment. And so they're actually really hard to formulate to deliver back to these environments. So whether that's your gut or the soil, or even the built environment and things like self-healing cement. And so what we try to do is develop materials that are based on bio-derived components, so things like green tea extract or components that are found in wine and coffee. And we can form little suits of armor on the microbes that protect them from these stressors and allow them to be delivered to where they need to go. Microbes can be used for many different industries. Right now, one of the areas we are very focused on is microbes in agriculture, mostly because in native systems, that's what supplies nutrients to plants and protects them from pests and things like that. So the fact that we use chemical fertilizers and pesticides right now is basically destroying what was natively there. So right now, the microbial agriculture market is about a $4 billion market, which sounds large, but the agrochemical market is $250 billion. And we think with our kind of nano suits of armor that allow us to make these microbes and manufacture them at scale, that we can deliver these and replace a lot of those agrochemicals. So when we think about agriculture, it's actually one of the major contributors to greenhouse gases. So CO2 emissions from one of the main processes to make nitrogen fertilizers represents about 2% of global CO2 emissions, and agriculture in general is about 11% of US CO2 emissions, so it's a pretty significant contributor. This is mostly because of the production and transport of those agrochemicals. We see innovation in the space as people trying to make those chemical processes greener. That's a lot of what organic farming is. But what we really want to do is move from chemicals to what we call regenerative agriculture, which is the idea that if you deliver live microbes back to the soil, they'll be able to sustain themselves and keep the soil healthy for long past just the application of those microbes. So right now, most of the people working on regenerative agriculture are very wealthy farmers. So the challenge with not being able to store and transport microbes is that you can't transport them to where they need to go. So Brazil is one of the leaders in these techniques, generally, regenerative ag. So wealthy farms there have these giant fermenters on site where they can deliver the live microbes. The problem with that is that it's very limited in who has access to this technology. And so bringing it back to our lab's goal of energy equity, we wanted to develop a way that everyone had access to this technology, not just people that can afford these fermenters. And this challenge in formulation has been a problem for about 3 or 4 decades with very little innovation in the space. People have added chemicals to stabilize microbes and other biologics, mostly for human consumption for biotherapeutics, but none of them really work. So we found these networks that are comprised of basically minerals that you would take in vitamins every day, plus these components like green tea extract. And they make these little cages that protect the microbes from outside stressors.